Hello everyone, I am Muhammad Kamran Halil from YouTube channel The Twins Academy. Today we will discuss the solution of the past paper related with the AS Physics May June 2023 variant 22. So question number 1 is related with the basic definition, the pressure. So how can we define pressure? The force. So we will change it with the red one. So force acting per unit area which is held perpendicular in the direction of force, which is normal to the direction of force. If this definition will be asked contain 2 marks, then you will write it down and you will get 2 marks. And if that definition is required for 1 mark, you will get 1 mark. So always remember, write down the complete definition. Now the next question is that using the answer in A1, show that SI base unit for pressure are kg, m-1, s-2. So using the answer in A1 made that pressure is equal to force over area. Now force that is equal to mg and then area meter square. Now the unit for the mass is kg, unit for the g is ms minus 2 and meter square. So now we will solve these two terms and then we will get kg m minus 1 s minus 2. So we will get 1 mark. Now for the next question, he is saying a horizontal pipe has length this. So what is required? The SI base unit for K. So first of all, make K as a subject and just ignore the constant. In this question, the constant are pi and 8. So we will make K as subject. So pressure P2 minus P1 is also pressure. Then R power 4, R is the radius, then density, and then T is the time. Always read the quantities and then you will write down their particular units. So divided by M into L. L is the length. Now we will substitute the unit pressure. Already we have done that kg m minus 1 s minus 2 kg m minus 1 s minus 2. Then r is the distance, radius, it is a m power 4. Then density, mass over volume, kg m minus 3. Then time is in seconds over the mass is in kg, the length is in meter. So then we will solve it. Kg will cancel out by this m3, this will cancel out by this, and s minus 1 from here. So which thing we have left? Only we have left kg m minus 1 and s minus 1. That is the answer of this question. Now an experiment is performed to determine the value of K by measuring the value of the other quantities in equation B. The value of L and R each have a percentage uncertainty of 2%. Now we will write down the percentage uncertainty for L and R. Now the question is state and explain quantitatively. So it means that we have to give the evidence that which one of these two quantities contribute more to percentage uncertainty in the calculated value of K. So from L and R, which will contribute more? So if we will observe the expression, we can see that L and then R as power of 4. So uncertainty for L will be 2%, and then for R power 4, the uncertainty, the power multiplied by 2%, so then it will become 8%. So it means that from this quantitatively data, we can see that R will contribute more uncertainty. So this is the question number 1 which we have done. Now we will move towards question number 2. This is the simple definition of center of gravity. Again, we will write down the complete definition. The point where all the weight of object, the point where all the weight of an object is taken to act, is taken to act. That is called as the center of gravity. Now in this diagram, what is required? That one force is acting on left hand side and two forces are acting on right hand side. One of them is 2.4 and other one is the force of tension. So he is saying that by taking the moments about the pivot, calculate the tension T in the string. Now you can see that on the left hand side the force is 54 Newton. So the moment on the left hand side will be greater as compared to the consideration of the only one force 2.4 Newton on the right hand side. But since this system is in equilibrium, it means that the string is also providing the clockwise moment, due to which the whole system is in equilibrium. So what we will do before solving that, we will calculate this distance 0.95, because we always take distance from pivot. So 0.35, and then it will become 1.3 for the string. The distance from the pivot is 1.3. Now we will resolve these two components, and now along x-axis and along y-axis, because we do not need this component, so we only need the y component, which is t sine 30 degree, because this is the moment which will act in downward direction. Now we will make the equation. We will write down the formula. F1 into d1, that is equal to F2 into d2 plus F3 into d3. Substitute the values. 54 multiplied by 0.45, that is equal to 2.4 into 0.95, then plus F3, so t sine 30 multiplied by, now what is the total distance of t sine 30 is from the pivot is 1.3, and after solving that we will get the value 34 Newton. That is the answer in two significant figure. In the next part, he is saying that the string is cut so that the beam is no longer in equilibrium. So when we will cut down the beam, then what will happen? The anti-clockwise movement will be greater than clockwise movement. So he is saying that calculate the magnitude of the resultant moment. So resultant moment will be calculated by subtracting these two moments. So on left hand side, what is the moment? We will calculate 54 into 0.45, 54 multiplied by 0.45. So on left side, the moment is 24.3. So anti-clockwise moment is 24.3, while for the clockwise moment only for the weight, not for the string. So clockwise moment is 2.4 into 0.95. So 2.28. Now we will subtract these two values, 24.3. We will get answer 22 point. So after subtracting that, 24.3 minus 2.28, we will get 22.02, but for the 2SF, the answer will be 22 Newton meter. Always remember, write down the answer in the least significant figure, which is in majority of the cases 2SF. The beam is rotated when the string is cut and the small block of the 2.4 Newton projected through air, like this, that when we will cut this string, this one, then what will happen? This load will be projected like this, because this anti-clockwise movement will be greater, so this load will move in a projectile motion. So now this question will move towards the projectile motion, the kinematics. He is saying that when the spring is cut and the small block of weight 2.4 is projected through the air, the diagram 2.2 shows the last part of the path of the block before it hits the ground at point Y. At point X on the path, the block has a speed. Now it means that at point X it has the kinetic energy as well as it has the potential energy. So both energy will be over here, kinetic energy, and the other one is the gravitational potential energy, because it is speed and it is above some altitude with respect to the ground. Calculate the decrease in the gravitational potential energy for the block as it's moved from X to Y. So now what we will do, we will first of all write down the formula. So GPE, always remember, write down the formula, mgh. Now what is the value of m? M is not given. Instead of that, directly the value is given in Newton. So it means that 2.4, and then we will multiply it by 1.8. So 2.4 and then multiply by 1.8. 4.32, we will get answer 4.32, and after rounding off, and we will get 4.3, and the unit is always written the joules. Use your answer. And conservation of energy. And conservation of energy, determine the kinetic energy of the block at Y. Now it is already in movement. So it means that at block Y, it has GPE, which was initially at 1.8, and then the kinetic energy. In this question, he has told that by using the law of conservation of energy. So at Y, it will be sum of the kinetic energy as well as potential energy. So now what we will do, so for Y, the total energy will be sum of kinetic energy plus GPE which is already 4.32. So apply the formula, half mv square plus 4.32. The mass is not given. W equal to mg, we will apply that formula. So W equal to mg, and m, that is equal to W upon g, so which is 2.4 over 9.81. And what was the value of the velocity? We will move back. The velocity is given 3.4, so 3.4 square plus 4.32. Okay, 3.4 square multiplied by 2.4 divided by 2 divided by 9.81, and then plus 4.32. We will get 5.73. 5.73, so 5.7 will be the answer. State the variation, if any, in the direction of acceleration of the block as it moves from x to y. Else, we know that the block is coming in downward direction, so acceleration will remain same in downward direction. So the direction of acceleration is downward. The direction of acceleration is in downward. As it is a projectile motion, so the next part is also related with the projectile motion. The block passes point x at time tx and arrives at point y at time ty. On figure, sketch the graph to show the variation of the magnitude of the horizontal component of the velocity. Now, you already know that for a projectile motion, there is change in the vertical component of the velocity. The horizontal component of the velocity will always remain same because that is not affected by the force of gravity. So what will be the shape of the graph? The horizontal velocity will remain same, so the graph will be a straight line, and then you will get 1 out of 1 mark. So that question contained 12 marks. Now moving towards the next question. A block is pulled by a force in a straight line along a rough horizontal surface as shown. The resistive forces in backward direction is 0.8, and then the object is moving in this direction with the force x, that is the force which is applied in the forward direction. Assuming that the total resistive force opposing the motion of the block is 0.8 at all speeds. The variation with the time t of the magnitude of the force is shown in diagram, which is given 3.2. So in this diagram we can see that. So define force. So it's very simple definition that rate of change of momentum is called force. So rate of change of momentum is called force. Determine the change in momentum. Now it means that delta P is required. As we know that the time is given, as we know that the force is that is equal to rate of change of momentum. So we will make delta P as a subject. So that is equal to delta F into T. Now the time interval we can calculate over here. The time interval will be 3 seconds, 3.0. And now what is the change in force for first 3 seconds? So we will move back onto the diagram, and then it is 1.4, and this is line, this one, this is 0.80. Now we will substitute the values. So 1.4 minus 0.80, and then we will calculate it 1.4 minus 0.80 and then multiply by 3. We will get exact 1.8. So in this question we will not do any rounding of data because the answer is already in 2SF. Define and explain the motion of the block between t equal to 3 seconds up till t equal to 6. Now from t 3 up till t 6 seconds there is no change in the force. It means that the force is constant. So then what we will write down, the forward force is equal to the backward force. It means that the resultant force is 0. So the resultant force is 0 because with respect to time it is not changing, and he has told already that the backward force will remain same. So forward force will cancelled out by the backward force, so resultant force is 0. And whenever the resultant force will be 0, there are two possibilities: whether the object will be at rest or it will move with a constant velocity. And in the question he have told that it is already in motion, so object will move with constant velocity. Now the next one. Force X produces a total power of 2 watt. The power is given. Then the time, again the two times are given, 3 and 6. So it means that again 6 minus 3 will give us 3.0 seconds. So this is the time which we have. He is saying that calculate the distance moved. Now we know that velocity, that is equal to distance divided by time. So distance, that is equal to velocity into time. Now what we will do, we do not have velocity right now. So in order to calculate the velocity, we will apply formula. The power is given, power that is equal to F into V. So the power is 2 and the value of F is given. What was the value of force at 3 seconds? Move back to graph, 0.8. So 2 into 0.8 into V. So first of all we will calculate the value of V. So 2 divided by 0.8 and then we will get 2.5. So V that is equal to 2.5. So we will substitute it over here. 2.5 multiplied by 3 seconds and then we will get 7.5 meters. So again I got answer in 2SF, so no need to convert. The block is at rest at time t equal to 0. It means that the graph will start from the origin. On figure 3.3, sketch a graph to show that the variation of the momentum of the block with time t from t equal to 0 up till t equal to 6. So the graph will be a straight line up till this. Now there is no change in the value of the force, so it will become a horizontal line. Now we will move towards the next question. That question is related with the Hooke's law. So a spring is suspended from a fixed point at one end. The spring is extended by a vertical force applied to the other end. The variation of the applied force with the length L of the spring is shown in the diagram 4.1. Now for the spring, state the name of the law that gives the relationship between the force and the extension. So I've already told you that this question is related with the deformation, and in the deformation we have only one and one, the Hooke's law. So we will write down the Hooke's law to secure 1 mark. Now he is saying that calculate the spring constant in Newton over meter. Now you can see that this unit is in centimeter. One thing more, this graph is between the length and the load. If the graph will be given for the load and extension, then this graph will be a straight line passing through the origin. So this graph is not related with the extension, this graph is related with the length. So what is the unstretched length is 8. So now we want to calculate the spring constant. The formula for the spring constant, F dat is equal to Kx, where x is the extension. So make K as a subject, that is equal to F over x. Now the value of force which we will take is 12. Now what is the change? For 12 the value is 24, and then the other value is 3, sorry 8. So what we will do, we will do the calculation. 24 minus 8 and then divided by 100, because we want to convert it into meter from centimeter. 0.16. So what we will get, the answer is 75. The next part related with this, determine the elastic potential energy when F equal to 6 Newton. Now for 6 Newton, we will shade that region, and area under the graph will be, now again first we will calculate the difference. So difference we will calculate over here, 16 minus 8, that is equal to 8 centimeter, or it will become 0.08 meter. Now this shape is a triangle, so the base is 0.08 and the value is given 6. So we will apply the formula. First of all, write down the formula, 1 by 2. So elastic potential energy EP, that is equal to 1 by 2 Fx. Then substitute the correct values, 6.0, and then the other value is 0.08, 0.080, and let's see what is the answer we will get. 0.08 multiplied by 6 divided by 2, we will get 0.24. 0.24. Moving to question number 5, that is related with the basic definition of the transverse wave and the longitudinal wave. So in the transverse waves, the particles will move perpendicular to the direction of the transfer of energy. So compare the direction of line P and Q. So for this, they will move perpendicularly. They will move perpendicular. And for the longitudinal wave, they will move parallel. That is the basic difference between the transverse waves and the longitudinal wave. Now for the next question, the loudspeaker emits a sound of frequency 1.7 kilohertz. So first of all, we will convert into hertz, 1700. The speed of the speed of sound is 340. A stationary wave is formed. Antinode at A, and at the open end of the tube there is only one other antinode. So for the dead end there is a node, and for the open end it is a antinode. So what can be the diagram of this? Is 1 by quarter of the wave, and then another half wave will be at this point. So this is the node, then again this is the node, and this is the antinode. Now this is the half wavelength with respect to the stationary wave, lambda by 2, and the distance between node and antinode is lambda by 4. This is what we got it from the given statement and the values which we have assigned on the diagram. Calculate the wavelength of the sound. So we will apply the formula V equal to F lambda. So lambda, that is equal to V over F. So that is equal to 340 upon 1700. So let me check what is the answer. 340 divided by 1700. So we get 0.2, but we will not write 0.2, we will write on 0.20. So do not lose one mark kindly. The length L of the tube. Now for the length, we will have lambda by 4 and then plus lambda by 2. So 4 lambda plus 2 lambda. So 3 lambda by 4, that is equal to 3 lambda by 4. So we will substitute the value 3 into 0.2 upon 4. So multiply by 3, already 0.2 was on my calculator, divided by 4. So we will get 0.15. Again the answer is required by the 2SF and it is in the 2SF. So the maximum wavelength of the sound from the speaker that can be produced by a stationary wave in the tube. So now what we will do, we will redraw the diagram and then now for this length lambda equal to L. Then for this one lambda by 2 equal to L, so lambda that is equal to 2L, and then for this it is the 1/4 of the wavelength. So this is node and this is antinode. So we will draw it over here. Node and antinode over here. Node and antinode over here. So this is node, this is AN. So now the distance between A and N is lambda by 4. That is equal to L. So lambda that is equal to 4 into L. I think the answer was 0.15. So 4 into 0.15 that is equal to 6.0. So this is the answer for this question. Now two polarizer filters are arranged so that their planes are vertical and parallel. So this question is related with the Malone's law. So now in the first diagram the angle rotated is by 35 and then in the second diagram the angle is alpha. So what is the total angle rotated when the light will pass through the second filter? It means that this so now what we will do, the input is this but we do not have output for this, and this output will become the input for the second polarizer. State the intensity of the light transmitted for the first filter is 5.7. We have to prove that. So I that is equal to I naught cos square theta. So I that is equal to what was the maximum intensity? 8.5 as shown. So 8.5 into cos square 35. We will solve it and we will get 5.7. Now this 5.7 is 5.7 is input for the second polarizer. So now for the next one, this alpha is actually the sum of theta and 35 degree, which was already rotated. What we will do, we will have to calculate the angle alpha. Alpha, that is equal to theta plus 35 degree, but we do not have theta. So for this we will use this as a input, and that is the output, sorry, and this one will be input 5.7. So we will apply the same formula and calculate theta. I, that is equal to I naught cos square theta. So we will substitute the values very carefully. What was the maximum? The maximum was 5.7. That is the input. The output is 5.2 into cos square theta. So we will calculate the theta, which is equal to 17 degree, and now 17 plus 35, we will get 52. The degree sign is already over there. Now we moving towards the next question related with the current electricity. So in this question, the current in the filament lamp decreases. Okay, fine. When the current will decrease, state and explain what will happen to the resistance. The resistance is directly proportional to temperature. So when the more current will pass, then the filament will heat up more quickly. When the current will decrease, the filament temperature will decrease. So when temperature decrease, it means that the resistance will also decrease. So state and explain how the resistance of the filament changes. State and explain the resistance decreases. The first thing which we will write down, the resistance decreases because by decreasing current, temperature decrease. By decreasing current, temperature decrease. Now the next part is really very interesting. So there are no calculation related part in this, but you have to try the expression. So now he's saying a cylindrical wire has length L. Now we will draw a cylinder. It has length L. The total length for the cylinder is L. Okay. It has resistance R. The total number of free electron charge carrier contained in the volume E is N. Number of particles are N, and each free electron has charge E. So the total charge represented by this system will be N into E, because Q, that is equal to N into E. If there are 100 million charges and charge on one electron is 1.610 is for minus 90. So this is the way we can calculate the total charge. The potential difference between the end of the wire is V. So now the voltage between the wire is represented by capital V, and we will differentiate that because we require the velocity as well in this expression. Okay, ji. Now he is saying that determine expression in term of sum or all. So write down the expression for the current. So simple, I equal to V over R. We will not use any other symbol except the symbols given E, L, N, R and V. So I equal to V over R. Now for the next one, what he is saying that calculate the average drift speed for free electrons. So what we will do, we will start it from the very basic definition of the current, and then we will move forward. So how we will proceed? So first of all, we will write down the expression for the current, which we have already written. I, that is equal to V over R, but the formula for the current is I, that is equal to Q upon T. Now since we have written that Q dat is equal to N into E, so we will write it down Q dat is equal to N E over T. Now speed that is equal to distance, which is L in this case over time. Because we do not use the symbol T, we have to use the symbol E, L, N, R, and V. So what we will do now, instead of T, we will use L over V. So N into E upon L over V. So by doing the reciprocal process, we will get what we will get now. We will go in upper direction, V N E over L. So I equal to V N E over L. Now this is the speed. We will make this as a subject. So V that is equal to I L over N into E. Now for I we have already V over R. So V into L over R N E. So this is the expression which is required to drive. Because in the final expression we do not have any other symbols which he have told that use this symbol, maybe any one of the one or all the symbols according to the condition. Now for the time expression we have already calculated for the total movement of the charges. So the time that is equal to distance over speed. So time that is equal to distance is L over speed. For speed we have already calculated the expression in the part 2. So L over V L over R capital and small e. So this L will be cancelled out by this one. So N R E over capital V. So this is the derivation related with this question. Moving towards the second last question that is related with the potential divider. So in this question he is saying that calculate the potential difference across the LDR. So what we will do, we will sign the symbols, then this is a series combination. In series combination the voltage will always split. So it means that we are required to calculate the voltage across this one. So we will apply the formula. The formula is V1 that is equal to E, which is EMF, into R1 over R1 plus R2. So the value of E is 9 into 1800, 9 into 1800 upon 1200 plus 1800, 1200 plus 1800, and then we will solve that and we will get answer which is 5.4 volt. It means that 5.4 volt will drop over here, and 5.4 minus 9 will give us 3.6 volt over here. Now the next question is related with the potentiometer. Next part related with this question. The circuit is now modified by adding a uniform resistor of wire XY. So the length of the wire, what is the length of the wire? 1.2 meter, across which how many volts will drop for this length XY, which is 1.2 meter. The voltage drop, which is, let's suppose it is V1, that is equal to 9.0 volt. Because this information will be required in the next part, what we will do, he is saying the length of the wire XY is 1.2 meter, the movable connection Z is positions on the wire XY, so galvanometer reading gives us 0. So what was the voltage at this? It was 5.4 volt, and for the rest will be 3.6 volt. Now he is saying that calculate the length xz along the resistance y. So what will be this length? We will use the unitary method. So that is a simple one, or we will apply the formula L1 over V1, that is equal to L2 over V2. So L1 in this case is XY, which is 1.2. So 1.2 upon the value of the voltage, I think was 9. That is equal to L2 is required, and the potential drops here is 5.4. So 5.4 into 1.2 upon 9. So the value of L2, which is equal to XZ, in this case it will become 0.72. The environmental condition changes causing a decrease in resistance of LDR. So in LDR, the light intensity and the resistance are inversely proportional. So resistance decrease means that the light intensity will increase because they are inversely proportional. So the intensity of the light illuminating the LDR will increase. Definitely it will increase. So when the resistance will decrease, it means power loss will decrease. So power loss will decrease means that total power of the battery, it will certainly increase. And the length x, that gives the galvanometer. Now it will gives us the zero or the null value at less distance, so it will decrease. Why it will decrease? Because resistance and length are directly proportional to each other. So if the resistance will decrease, it means that the length will also decrease. So here we go with the last question related with the nuclear physics. So he is saying that P and Q are the isotopes. It is emitting beta negative particles. For nuclear P and Q, compare the number of protons. So number of protons will remain same. There will be no change with respect to the definition of the isotopes, while the number of neutrons will be different. So that is the basic difference between the isotopes. Okay, when nucleus Q decays from nucleus R, Q decays to form nucleus R, and it is emitting the beta negative particle. So when beta negative particle will emit, what will happen? The down quark will convert into up quark with the emission of beta negative particle, or we can write down the equation. So when beta negative decay will convert, negative means that neutron will convert into proton. I have remembered from this beta negative mean N for negative and N for neutron. So neutron will convert into proton plus minus 1 0 and plus anti-neutron. This is the complete equation. So we can write down, state the change of the quark composition. Rather, you can write down that the down quark will convert into up quark, or for the neutron. For the proton, it is up, up, down. So up, down, down. So we can write down it in either way. Either you can write down for this particular question whatever you want to write, that the quark changes up, down, down to up, up, down. So you can write down this answer for this one, or you can write down this answer. So option A you may write, or option B. Both options are acceptable for this one. State the name of the other particle. So other particle emitted is the anti-neutrino. So anti-neutrino is the other particle which will emit in case of beta negative, and neutrino will be emitted in case of beta positive decay. A hadron consists of two charm and one bottom quark. So 2 charm plus 1 bottom quark, the value for the charm is 2 by 3 E. So 2 into 2 by 3 E plus for the bottom quark it is minus 1 by 3 E. So it will become 4 by 3 E minus 1 by 3 E. So the answer will be plus 1 E. Plus 1 E. So I hope that you got good understanding of these questions. So if you have any query related with the questions, so do not hesitate to send me the comment, and also like this video and share with your friends and colleagues. Thank you very much. Stay tuned for more 2023 papers related with the A levels. Take care. Bye.